We're going to turn this fire extinguisher into an old military stove that we'll also use to cook food in extreme environments. Its highly efficient pyrolytic system will keep us warm for many hours with just one load of pellets or wood. Stay until the end of the video to learn how to make it and see how it works. We start by taking this old fire extinguisher. We disassemble the hose, the pressure gauge, and the valve. We'll need to apply a little force to loosen it. We empty the powder inside. Now we use a large nut and a permanent marker to trace the cutting area. We cut with a circular saw. And now we use this piece of iron to trace the other cutting line. And we cut this other section. This cylinder will be the body of the stove. Now we trace this new line. And we mark the points where we'll make large holes. We mark the centers of the holes with the center punch. First, we make a small hole. Now we'll hold it securely in the vise so we can drill with this 35mm diameter hole saw. Now using this template, we'll draw some cutting lines. We'll do this by joining every 2 circles with a line and cut. With the holes and cuts, we've made legs for our stove. We'll remove any burrs. This way we'll leave a smooth surface. Using this part we previously cut from the fire extinguisher, we'll make the bottom of the stove. We drill a 35mm diameter hole in the center. We'll cut along this new line we're tracing. By removing this strip of metal, we reduce the diameter of the piece. Now we remove all the burrs. We'll also need a 35mm diameter iron pipe. We'll draw a line at each end, about 6mm high, and with this template, we'll mark the points where we'll drill. We repeat the process on the other end of the pipe. And we mark all the trace points. With a 5mm drill bit, we'll drill a hole at each of the marks. This process must be done precisely so that the holes are evenly spaced and do not skew. We repeat the process as before on the other end of the pipe. Using a countersink, we clean the burrs from the holes. Now we need to draw a line connecting each hole at one end with the opposite hole at the other end. We continue making a groove on each line that joins the 2 holes. To do this, we'll use a grinder with a cutting disc. This is the most delicate process in the entire manufacturing process and requires great skill in handling the angle grinder. Using a sanding disc, we remove all burrs. Using this blowtorch, we perform a thermal stripping process to remove the old red paint from the fire extinguisher. We'll apply heat until all the paint is blackened and blistered. Then we'll scrape it off with a wire brush. Will only be finished when the entire structure looks completely metallic. We'll mark another hole, which we'll drill and thread to a size 8 thread. we'll screw in a size 8 bolt, and on the other end, we'll screw on a nut, which we'll later weld. We can now remove the bolt. It's time to weld these two pieces together. We'll place them like this, and we'll join them with a series of spot welds. As always, we smooth the surface, and we've got a perfect assembly. Now it's time to join it to the stove body. This piece will be the bottom of our stove. After placing it, we join it with spot welds. And we smooth all the surfaces again. The central tube must be perfectly centered inside. These two pieces will serve as handles for carrying the stove. Using this 4mm thick metal sheet will make the burner, which will also be the lid of our stove. Using the compass, we'll trace a circle around the stove's outer diameter. Now we'll draw 3 lines offset by 120 degrees. Now using a 40mm diameter bit, we'll drill a hole in the center. Using the angle grinder, we'll trim the corners and give this piece a circular shape. We now have our custom-made lid. Now we'll weld these small pieces to each of the lines we drew. These will be the cooking supports. Now we'll attach this trap door to the threaded hole we made previously. With this trap door, we can adjust the airflow to regulate the flame. All that's left is to weld a hinge to the lid. With this, we'll have finished manufacturing. Now we're going to paint it. This is a special heat-resistant paint for stoves. This will ensure it doesn't deteriorate with use. And it's ready to start heating us up. Let us know if you like how it turned out, or if you would have done anything differently. Let's start it up to see how it works. We'll use these pressed wood pellets. During the First World War, soldiers used thin wooden branches that they inserted vertically around the inner tube. We'll fill it with pellets, trying to make sure none remain in the inner tube. We open the air inlet and insert some pieces of paper to start the combustion. It seems to work perfectly. After 2 minutes, the pressed wood pellets heat up. As it heats up, it begins to expel combustible gases. These gases fuel the fire very efficiently. The stove must be in a well-ventilated area to avoid inhaling carbon monoxide, which is highly harmful. It starts to get cold around this time of year, so to test the stove, we took it camping. We're setting up our tent for an especially cold night. During the day, the temperature is mild, but at night it drops drastically in this area. We're going to surround the stove with stones to prevent an accidental fire. This larger stone will be used to sit by the fire. With these 4 small logs, I'll make a makeshift table. I'll tie them tightly with rope. And this way, I'll have a raised surface to put some things on. We place our military stove inside the safety zone marked with stones. Here we see how the air intake hatch opens and closes to fuel combustion. We fill the container with pressed wood pellets. This can be made with any type of wood, nutshells, olive pits, etc. We can adapt it to whatever fuel material we have on hand. Include the most commonly used fuel in your country in the comments. Now to start combustion, we'll place small, dry branches and some paper inside the inner cylinder. The operating principle of the pyrolytic stove is decomposition by heat without oxygen. This means that when the pellets begin to heat up inside the lower compartment, they don't yet burn, but instead release combustible gases such as carbon monoxide, hydrogen, and methane. These gases rise and mix with the air entering through the lower hatch. This mixture ignites and burns with a clean, powerful flame. In a normal campfire, much of the heat and fuel is wasted in the form of smoke and unburned gases. But in our pyrolytic stove, that smoke is burned again, utilizing almost all of the wood's calorific value. In addition, the pellets produce charcoal, which ultimately remains at the bottom as a solid residue. As you can see, the result of this military stove is more heat with less fuel, almost no smoke, and a more stable and long-lasting combustion. After a day of work making the stove, we're preparing a small feast. This will give us energy to face the cold with more calories in our bodies. The meat looks delicious. Let's try this sandwich made with our homemade military stove. But first, we'll remove the pan from the heat. Night falls. If you've reached this point in the video, it would be a great help if you could show us your support by giving us a like, leaving your comment, and subscribing to our channel. Thanks to your help, we can continue creating interesting content. Our little military stove generates a very pleasant warmth, even in the cold. But that's not all. With this bent stainless steel plate, we're going to project that heat toward our tent. This way, less heat is wasted and it's focused on a specific area. We're going to prepare a small dinner just like they used to do in the old days. We'll skewer the sausages on this sharp stick and put it directly on the fire. It looks like it's ready to eat. It's delicious. It's time to go to sleep. The heat from the stove has warmed the tent enough for us to spend the night peacefully. Good night, friends. Thanks for watching the video. If you want to support our videos, you can become a member and subscribe to our channel. See you for the next invention.